I am Olivier LY from Bordeaux, and I represent the Acroban humanoid robot. It has been designed in INRIA and Bordeaux University in the LABRI. Okay, so this robot has two main characteristics. I mean, we are interested in first in morphology, in the morphology of the robot, and then in mechatronic. In the morphology, we are interested into the vertebral column. I mean, the vertebral column is bio-inspired. It catches the essential joints of the human being vertebral column. I mean, here we have 5 joints in the vertebral column and more in the pelvis as well. So, second, we are interested into the compliance. I mean, this robot is compliant, which means that I can interact with him, and he will fight to get the balance. I mean, to get equilibrium. You know, when I move it here like that, you can see the pelvis moving to keep equilibrium like that. So, from the point of view of computing, it is a distributed machine. Actually, there are here 26 joints, and in each joint there is a motor, of course, but there is also a microcontroller which enforces a feedback loop, a local feedback loop, which receives order from a central unit, which is here, and which is composed of 2 microcontrollers. I mean, a first one, which is quite simple, an ARM7, which does real-time tasks, which mean the move scheduling and the enforcement of mid-level controller. And then there is also a microcontroller which enforces high-level treatment, I mean mathematical learning algorithms and this kind of stuff. So we are interested in this softness of the robot, and actually because for 2 points, the softness is used as a controller, as a natural controller, as a mechanical controller, which means that the robot is soft like that, and for example, the arm acts as a pendulum, and the vertebral column acts as an inverted pendulum, and well, these elements, these mechanical elements, compute a control, but the computation is just done by physics. So, which means that if we have an elastic, then it reacts instantaneously, which is the better controller, of course. But it is difficult to adjust it, of course. But the robot is compliant and flexible. We use this compliance to enforce physical interaction with human. If you think about personal robotics, you have to deploy robot at home and in the everyday life, you know. And so, first thing, I mean, the immediate interaction that we will have is a physical interaction. For example, I would like to learn a move to the robot, then I can take his arm and do it that. And so, even for the locomotion, I mean, when I make it work like that, I can take the arm and indicate to the robot where to go, like that. And this physical interaction was quite new, and it is done by the control, of course, the central unit, and each unit in each motors, but also by the physics itself. I mean, the elastic like that enforce reaction, I mean direct physical reaction, which is immediate, and so on.